All right, everybody. Welcome back. This will be week 3 of the lab, if I'm not terribly mistaken.
Maybe week 4, I think.
Maybe week 4.
Yeah.
Whenever it is, we're happy to see you again.
So this is the second carbohydrate lab where we're going to be measuring the glucose concentration in beverages.
Yeah.
Yeah.
So the idea here is that we've now set up a standard curve for our assay. So now we can take any beverage, any sample, any fluid really, and we can determine how much glucose is present there. So there are a few things for us to go over. We're going to be doing a demo with apple juice, which of all of our options is the highest carbohydrate concentration, our highest sugar concentration beverage. You'll see on Canvas that we have 10 different beverages that you can choose from in order to do your assay. If you were in lab, then we would have these all sitting out and you would just collect them and do the experiment yourself. But instead, we'll be doing 10 different assays determining glucose concentrations there.
Okay. So what you want to do is when you decide or when you get allotted which beverage you're going to do, you look at the nutritional information, and on the back here it tells you the number of carbs. So 34 grams of carbohydrates per serving, and it says the serving size is 1 bottle, which is 295 mils.
So we have 34 grams of carbohydrates in 295 milliliters of fluid.
Mm-hmm.
You can convert this simply to the number of grams per milliliter. So if it's 34 grams per 295 milliliters, it's just 34 divided by 295, and you get 0.115 grams per milliliter. You can convert this over to micrograms per milliliter, which just makes sense because our standard curve used concentrations of micrograms per milliliter. So, Bridget, can we just take the apple juice and pour it into a tube and add DNS and do our samples?
Well, our standard curve went to 1,000 microgram per milliliter, and our apple juice is 115,000 micrograms. So it would be somewhere down in room 128, I think.
If it's even in the building.
Yeah. So no, we can't. We're going to have to dilute it first.
And that's a key point, right? When we're using a standard curve, we can only trust values that fall between our minimum and maximum known values of concentration. Mm-hmm. We can't extrapolate all the way out to higher concentrations.
Yeah.
Fantastic.
So if we take off, if we did a 1 in 10 dilution, it would still be too high.
Yep.
We did a 1 in 100, we'd still be too high, essentially. We'd be getting a little bit closer.
Mm-hmm.
So if we did a 1 in 1,000 dilution, we'd be a little on the low end. So our first number down here was 100. So we would be a little bit too low. So I think a good range is probably going to be between a 1 in 500 and a 1 in 200 dilution.
Yeah.
Okay.
And if we wanted to know what our concentration was, we can use C sub I times D equals C sub F.
Mm-hmm.
Initial concentration times our dilution factor equals our final concentration. So why don't we quickly show you how that would work? You take 115,000 for our initial concentration, a dilution factor of 1 in 200 for our dilution factor, giving us a final concentration of a number that I do not have prepared. So let's go ahead and quickly have Bridget calculate that for me here. So dilution factors, right? What they mean, when you see this 1 in 200, it means for every 200 units of final volume, there is 1 unit of volume of your initial solution. In other words, a 1 in 200 dilution could be 1 microliter of your initial solution and 199 microliters of your final solution. Note that the units will cancel out here, meaning that a dilution factor is a unitless value.
575.
575, right in the middle. That is exactly what we want. And just for best practice,
Somewhere around here.
yeah, it's perfect. And remember, absorbance is going to be here. We'll measure that, and that will give us our value of concentration. And best practice is to have 2 different dilutions usually for something like this, set apart by a little bit. So that's why we're doing a 1 in 500 and a 1 in 200. Yeah.
So can I just take 1 milliliter and add it to 500 milliliters?
Well, if you don't mind having 500 milliliters of solution for a 3 milliliter reaction, so it would be better to not be so wasteful, especially when you're using things more expensive than, say, apple juice.
Yeah.
You can be a little wasteful with apple juice. We could make a gallon of the dilution and then just take out 3 milliliters. Like, why not? But we usually try to get around that using something called serial dilution.
Yay!
Yeehaw!
Students all around the world love serial dilutions.
Nobody loves it more than me.
Okay.
So, we know that we want a 1 in 200 dilution. Let's start with that. Just generally, mathematically, you probably know 1 over x times 1 over y is equivalent to 1 over x times y. Right?
Mm-hmm.
So we know we want a 1 in 200 dilution. So, how are some simple ways we could do this? We could do we could definitely do a 1 in 10 dilution, right?
I think that's a good place to start.
This is a great place to start for me. 1 milliliter into 10 to 9 milliliters, making a 1 in 10 dilution, meaning we still need a 1 in 20 dilution. So do we want to do a 1 in 20 or do we want to break it up more?
Why don't we do another 1 in 10?
Why not?
Yeah, just for the fun of it.
Just for the fun. We know how to have a good time in this lab. All right. So now we've taken care of a 1 in 100 dilution. This right here is equivalent to a 1 in 100. Then we drop a 1 in 2 dilution or a 1/2 dilution, and all of those multiply out to make a 1 in 200 dilution.
Mm-hmm.
Now there's one more trick here. Using a serial dilution, we make the first dilution, and then we take out of that tube, that now diluted tube, and use that to make the second dilution. Mm-hmm. So really quick, I'll draw that on the board to clarify, since this is a very confusing topic for a lot of people. Okay. 9 milliliters of water. 1 milliliter of apple juice. A 1 in 10 dilution. Yes, exactly. Now, 1 milliliter of our 1/10 dilution added to 9 milliliters of water. And now we have a total of a 1 in 100. So this would be the 1 in 10, 1 in 100. Now we want to do a 1 in 2 dilution.
Mm-hmm.
And we want to have a final volume of 3 milliliters.
Yeah, our reaction is 3 milliliters, so we want to have
At least 3.
Mm-hmm.
Yeah. So we have some options here. A 1 in 2 dilution could be a 5 in 10. It could be a 3 in 6. It could be a 2 in 4. Well, what would you like our final volume to be?
Let's do 5 and 10 because since
Why
the
not?
other ones are 10.
Yeah.
Yeah.
Never hurts to have a little extra material to work with. As long as it's not 10 gallons of extra material. So, 5 milliliters out of this into 5 milliliters of water. That's a 1 in 2. Just to be clear, 1 over 2 is equivalent to 5 over 10. Hopefully that's entirely intuitive. If not, talk to us. We'll try to get you right back on track. And there you go. That's a 1 in 2 dilution, giving us a total of 1 in 200. So
Okay,
here
and
we
then
stand.
the 1 in 500, we could use these two and then just do a 1 in 5.
Yeah, which would be equivalent to a 2 in 10.
Mm-hmm.
2 milliliters to 8 milliliters of water, and we've got a 1 in 500.
Okay.
And that is exactly what we're going to do right
now.
here for you.
Okay. So we're going to set those up nicely, just like Jonathan demonstrated on the board. So tube number 1, we need 9 mils of water. Tube number 2, we need 9 mils. Tube number 3, we need 5. And then we're going to do 2 plus 8 for the last one. Okay, thank you, sir.
It's my pleasure.
All right, so I'm going to pipette in the water first.
Actually, we in the background we have tubes boiling, and they are actually due to be taken out.
Okay.
Would you like to add in the salicylic acid while I manage this, or vice versa?
Sure. So
Cool.
you're going to do the water?
Absolutely.
Okay, go ahead. I'm
All
going
right.
to get the tubes out.
Thank you so much. Alrighty, so I know the volumes that I need. I'm gonna add 9 milliliters of water to tube 1. Perfect. 9 milliliters of water to tube 2. And only 5 milliliters of water to tube 3. Stupendous. All right. Now I know I'm going to also be doing that 1 in 500 dilution. So I'm going to set up the first 2 steps in the same way. We'll be adding, let's see here, be adding 9 milliliters of water to tube 1. Nine milliliters to tube 2. But this time, we only want a 1 in 5 dilution in the final tube for a total of 1 in 500. So to accomplish this, I'm going to add 8 milliliters of water to tube 3. And then we will add 2 milliliters of water, 2 milliliters of our previous dilution, giving us a grand total of a 1 in 500 dilution. There we are. We also have an extra tube, you might have noticed here, for our blank, which will still be necessary, more or less. Fantastic. How's that looking over there for you, Bridget?
All right, these are done.
Great.
Um,
So we won't be demoing all of these tubes, but you can see our already prepared dilutions for each of these 10
so
beverages.
we have all the 10 beverages here. Nicely set up, 2 different dilutions, a 1 in 200 and a 1 in 500 of each of them.
Yeah.
And just like we did last week, I boiled them, we added the DNS, and we boiled them for 15 minutes, and now we need to stop the reaction with the sodium potassium tartarate.
Sodium potassium. Did I say salicylic acid earlier? I think I did.
Well, they have salicylic acid in them. So.
That explains the confusion.
Okay, so we need to add 1 milliliter of the stop solution. Sorry.
Oh, no, I'm trying to stay out. I should try to stay out of your way. My job's easier.
Phone's ringing.
There we go. Oop. Perfect. All right. So you'll be seeing on Canvas the data that we're generating from these. But for the demo that you see online here, we'll be focusing on our apple juice sample, and that's it.
So the apple juice needs to get,
It does need its DNS, doesn't it?
yeah.
What volume of DNS are we adding again today, Bridget?
So equal to the reaction, so it's 3 milliliters.
Flawless. I am going to use a micropipette.
Okay, so these are good to go. I'm going to set them aside.
Perfect.
So we're ready for them.
Oh, I just need these ones. You'll notice that I'm only adding DNS to 2 tubes here. That's because the tubes that were used for the serial dilution, we don't need to run those. Those were just there to help us more accurately do a very high dilution factor with a very small volume of fluid.
Jonathan, are you doing a blank for the spectrophotometer?
We've already blanked it for the standard curve. We haven't changed any settings, but we can totally blank it if you'd be comfortable with it.
Yeah, I think we should do it again, just in case.
Why not? So equal volumes of DNS and water then, right?
Yeah.
Fantastic. So this will be our blank tube right here. 1, 2, and then 3. 3 mils of DNS. Now we need 3 mils of water. That's the pure water right there, right?
Yeah.
I'll just use the same tip. And 1, 2. And if I remember my training, that makes 3.
All
That
right,
needs
so
to.
now we can boil this.
Yeah, now we have
Okay.
3 tubes to boil. Oh, let's see here. I've got.
We heated up the water before we started, so
This should go. It should be very fast. 1 and 2, 1 and 5, and then our blank. So wait until it starts boiling a little. Great. Da-da-da.
okay.
Cool.
So I think that's good.
I think that's everything. What else will the students need to know? They've seen the running through of a spectrophotometer. So I think that we can, at this point, we'll be boiling these samples. We'll be running them through the Spec 20 just like you saw in last week's lab. And unless you have any objections, this is a good place for us to end.
Yeah.
So you'll see data, descriptions of your assignments. As always, reach out to us, talk to us. We're all lonely these days, you know what I mean? We can stand to see a happy face via Zoom or something like that.
Exactly. Or office hours even.
Yeah, how crazy would that be?
Yeah.
All right. Bye, y'all. Thank
Thanks
you
for
for
watching.
watching.